Oh boy. Uh-oh. Hello? We on? Are we on? Let me just double check. Hello? Hello? Okay, looks like we're on live broadcast. Double check. Oh, yeah, shut this thing off. Hello? How do we look? How are we? Wait, can you actually see anything? I can't see anything. The hell is this? Hey, CG Happy Mac, hello. Can you actually see anything? I can't see a thing. Like, can you see the screen and everything? Let's test this thing out. Hello? Alright, okay. I finally see it. It wasn't showing up on my phone. Okay, I wasn't seeing anything on the phone, so it's like, okay. Check, check. Check, check, 1, 2. Thanks, CG Happy Mac. Yeah, empty black box. Now it's Callie, right? Hey, Max, man. Hey, Max M, Max M. No, don't paste the screen cap. But you can now see it, right? Everything looks okay? Things are good. Audio good. Visual okay. Well, this is important to check. The reason why CG underscore Happy Mac, I can tell you now, is I'm sure you've all heard the news that Twitch got hacked badly. And anyone who streams to Twitch got an email this morning saying we need to change the streaming key and of course our passwords as well too. So yeah, I'm using OBS to stream. Yeah, so I had to do a few things. Um, change the streaming key, change my password. I had to do all that. So anytime you make those minor changes, who the heck knows if it's gonna run? That's the reason why. Yep. So here we are today. We're actually streaming, right after that Twitch got hacked. Oh boy. Yep. Happy Cybersecurity Awareness Month to everyone. All right. Ah, shoot. I didn't actually make a note of this. Darn, I should have posted. I didn't actually post anything on Twitter saying that this is gonna be live, but that's okay. That's okay. Yeah. Hold on. Maybe I'll make a message right now. Hang on. I'll just make him know. Password cracking. John the Ripper. Etc. All right. It's like, oh man, I gotta post this thing right now. Yeah, I think that's a good tweet. There you go. Doesn't block for me either. Should we have anything installed for this lab? Yeah, you definitely need John the Ripper. So default user, we need John the Ripper. Allo, problem is, yeah, ad blocker doesn't even block my Twitch ads either. Then again, a lot of these streaming services, like YouTube, for example, a lot of these places have now gotten pretty smart on how to bypass ad blocking. Yeah. Anyway, 4:31 right now. Hello, everyone. Welcome to another episode of Introduction to Security at Tufts. I'm Ming Zhao, Associate Teaching Professor. It's October. It is October 7th, and the first session in the month of October, and that also means National Cybersecurity Awareness Month. October is National Cybersecurity Awareness Month and Breast Cancer Awareness Month. You got two things going on. It's customary. I was looking back at this is the third year? No. Third time I'm doing these streams. And it seems like the schedule is pretty consistent. Fall 2020 and today, the first session in October was on password cracking. And so that's today. The point, what we're going to do today is we're going to do passwords and password cracking. Yeah, we're going to crack passwords. We're going to use John the Ripper. We're going to understand how passwords are stored on Linux-based systems. We're also going to talk about, we're going to start off with the wrong ways to store passwords and the right ways of doing so. Yeah. So it's all about password and password cracking today. Now, it is customary in my Introduction to Security class, each and every time I teach it, that we run a password cracking competition. And this year, this semester, the password cracking contest is now open. Hey, Freedom Pfeiffer. Here we are. This is the Fall 2021 Password Cracking Contest. This year, there are 16 password hashes to crack. The idea is students crack as many password hashes as possible. If you crack all 16, you get an automatic A for the course. No questions asked. Good luck with that, though. Good luck with that. It's an individual lab. Keep record. Students get the whole month to do this. It's going to be closed on Guy Fawkes Night, November the 5th. And the bar to get full credit on the lab is it's usually pretty fair and low. It's a very fun lab. But yeah, the key is get started on this early. And there's no limit on what infrastructure you can use. I mean, if you have all the money in the world, you're going to buy password cracking rigs. Okay? So this is one of the activities, this is the quintessential activity in my security class. It's also open to the public as well, too. Have any student ever cracked out a password before? No. Although there was one student, fall 2020, that was extremely close. So I was sweating bullets. That being said, I want to give a shout out to Matt Bender, who was too shy of cracking all the passwords in fall 2020. Yeah, so that was as close as I got. So I was sweating bullets then. He used some infrastructure, I know that, including a startup that does this stuff for a living. So, all right, okay. So there was that too. I mean, there was some crazy stuff that was going on. So I want to take a step back and want to understand, let's understand the wrong ways to store username and passwords. Let's understand the wrong way. So let's imagine that a company service, is maintaining username and passwords. So I'm going to draw this out. I'm going to give a few examples out here. I'm going to create this thing called username. and password. So we're going to create a table of usernames and password. Alright, so I'm going to make a few usernames and passwords here. Okay, so let's say that this company service website had 5 customers, 5 username and password. So I'm going to see Pfeiffer. And your password is programming. Now I'm going to have another username called Alon. And your password is, I'm just going to say football. Okay? So I'm going to make a few usernames. I'm going to make a few accounts here. I'm going to say that guy. And I'm going to make the password be whatever. Okay. I'm going to say bacon. Okay, bacon. EX360. And your password is going to be, I'm just going to make something up. I'm going to make your password to be eggs. Okay. Yeah, I'm going to say your password is going to be, why don't we do this? Eggs. 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 That's your password. Yes, I know. Right now we're going to say your password is football. We're going to say Fox01 in honor of Pathetic Fox. Your password is going to be Silver Fox. And we're going to make one more account, Samantha. And let her password also be football. All right. So imagine that a company or a website or service is maintained. Okay, we got 1, 2, 3, 4, 5, 6 users here. We got 6 accounts here. 6 usernames, 6 passwords. Now, imagine if the company or the service is storing these username and password as is. As is. Okay, as is, all in plain text. That's the key. We got a problem. So, look, if you do security, it's not a matter of if something is going to get hacked these days, but it's a matter of when. Hey, see Twitch. I mean, we're on this infrastructure right now. I had to throw that joke out there. I mean, I just have to say that. Like, look, always assume that it's not a matter of if, but a matter of when you'll get hacked. Always assume that. And when places get hacked, people love to dump, username and password. That's the first thing that a lot of people always want to get. So imagine if this company website that we're running right now, well, the database of username and password got packed, and here it is, right here as it is. So you got a couple of problems right here. So number one, we know that all the username and all the passwords are stored in plain text. They're all stored in plain text. I'm going to save this. I'm going to save this as users dump.txt. Yeah, I'm going to save it as a user dump. So first of all the username and passwords are all stored in plain text. The other problem is it's really clear what the username and what their corresponding passwords are. In this case, it gets even more interesting because now, with our own eyes, everything's in plain text. We also notice that there are 2 users that share the same password, Elon and Samantha. They both share the password football. Okay? So, awful way to store username and passwords is to store everything in plain text. That almost goes without saying these days. Unfortunately, you won't believe how many places still store stuff, sensitive information, in plain text. That's bad. That's just bad. form, even here we are in the year 2021. Okay, so we know that problem. So this is bad design 101. This is bad design 101. Everything's stored in plain text. There a way that we can do better? The answer is yes. We can do a little bit better. We can do a little bit better. And that is, okay, instead of storing sensitive information like passwords um, in plain text, what happened if we, store them that looks kind of gobbledygook? That, let's say that they are scrambled or encoded, and there's, you can't understand what the password is with your own human eyes. And that leads to the following step, which is an improvement. Okay, what if we stored the hash, something called the hash of a password? Okay, so what a hash function is, all right, a hash function is, think of it that is, a black box. You feed something into it, like plain text or data, and out comes some fixed length string of letters and numbers. Okay? So there are in cryptography, there are a number of what these are called one-way hash functions. Now, there are a couple of very important properties to have of these hash functions. Number one, two different pieces of data that are sent into the function should always have two different results. Two different pieces of data should never ever share the same, what they call the hash value at the end. So in other words, on a more technical terms, no collisions. Okay. Number two, a hash function is there's some level of randomness when you feed stuff in, so it's not going to be predictable. Number three, when you feed in a string, let's say the word programming, into the hash function, it should always produce the same result in the end. Okay? So an example, a very good example of a hash function is something called MD5. What is MD5? MD5 is called a message digest algorithm. Okay? It's still used quite a bit these days. But let's do this. Let's not use this one. Let's do MD5 calculator. Doesn't matter which one you use. I've never seen that one before. MD5 hash generator. Okay, here's one. So I'm using this. Use this generator to create an MD5 hash of a string. Let's say, for example, programming. I'm going to generate the hash, and here it is. Interesting. So I'm going to feed the string into a function called MD5. The resulting string is going to be this key called a hash. 7E73 yada 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 BB92. Okay? There is also another hash function that is called SHA-1. That is also very well known. It's also used quite a bit as well. If you're familiar with something like Git, for commit messages, Git commit messages uses SHA-1. MD5 and SHA-1 are two very, 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 very well-known hash functions. The big difference is the key, the resulting key length. And of course, logically speaking, does longer key length matters as it yeah. Also, hash functions are meant to be one way. There's no such thing as encrypting or decrypting. So if you receive a hash value of 7073 BB92, there is no mathematical way to go and reverse that and to get the original form, the original string back, which is programming. None. If I actually go and look for another MD5 calculator, if you go to another MD5 calculator out there, there's tons of them. You do a search on them, like this one, an online MD5 calculator. And what was it? The programming was the string that I want to encode. The MD5 and it should be the same exact value, 7073D067 yada 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 BB92. There we go. Okay? So, you can, whatever you feed into it, you can feed a string to encode, you hit the encode, it'll use the MD5 function. How MD5 works, the algorithm and the source code, all publicly available. Always made publicly available. We'll end up with something called, and you'll end up with something called an encoded string. Okay? So now, let's do this. Let's do this. Going back to this example. Whoop. Now, instead of storing the plain text of the password in the user dump in a database, why don't we store the hash value instead? So in Christian, we're going to use, let's use MD5, because MD5 is very well known. It's also simple. I'll get to a caveat in a bit. Okay. All right. Alon, let's do the MD5 of football. Okay. Yeah, so I'm going to make a copy of this. I'm going to send everyone. This is the MD5 calculator I'm using. Oops. Okay. What about this whatever? Okay, what about eggs, eggs, eggs? And you notice that with a hash function, the hash value is the same key length. Silver fox. Let's do the calculation for that. And one more. Football. We do football again. Yeah, 37. All right. Here we go. Well, it is a little bit better, a little bit better, a little bit better, a little bit better. All right, so now, instead, the big difference now is the password is no longer stored in plain text, but the password is stored as a cryptographic hash. In this case, MD5 hash value of the password. Now, remember what I said, a hash function, there's no way that you can go and reverse a hash value, any of these hash values, and get the original form back. So if you eyeball 37B4 yada 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 33C0, there should be no way to go and reverse this back into the original password, which was football. Okay? All right. This is a little bit of an improvement now. The password is not in plain text. I mean, it's not as glaring as the last example that we did. All right, so this service gets hacked again. Okay? So, well, get hacked again, which is normal these days to get hacked more than once. Someone dumped all the username and passwords again. But this time, okay, I see a whole bunch of usernames and passwords, but the password is hashed. But there is still a big problem. Actually, two of them. Number one, as you can see here, you can notice a very interesting pattern. Alright, although the password is hashed, so it's no longer in plain text, you can still see a certain pattern here. A pattern is that Alon and Samantha have the same hash value. Alon and Samantha have the same hash value, so that means Alon and Samantha must be using the same exact password. They both have the same exact password. That's not good. That's number one. Number two, the other big problem is, there are people have already calculated the MD5 hash value of every single dictionary word. Although you can't go back You can't reverse 37B4 yada 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 C0 back into the original, whatever the original text was. What you can do is you can do a simple search for let's say an MD5 hash, and you should actually see a bunch of results. There it is. Like, people have already, well, let me see if there's google.com. Let's see if Google does this. Aha! There it is. So, if it is just a straight hash value, people have already calculated the hash values of every single dictionary word. So if you do a search for the MD5 hash value of 37B4 yada yada 33C0, you can take a look at the result. Oh, okay. The hash, it came from the original form was football, unhashed. There you go. Okay, so that's a problem. So if you so now if you why is this a problem? Well, first of all, Elon and Samantha, actually both have the same password, but the problem goes deeper societally. Have anyone ever seen the list of worst passwords, like of the given year, like worst password of 2020? Okay, so the 10 most common password. Here's the thing: is the whole idea of people using the same password is pretty common. And the worst thing is, and there are plenty of articles out there that actually list like the worst, how many people are the password Hall of Shame. And these are the 10 most frequently used and worst password of 2020. And the uh, list of these 10 common passwords is pretty consistent almost every year. This is new. Wow, this one's Sen, huh? Okay. A lot of 123, a lot of 1234566, a lot of passwords, a lot of 1161, ABC 123. How do people? Well, how do people act? Well, no. This is a great question. How do people actually use password? Look, it's the Angel Peach 424. It's actually a good question, and it goes beyond the technical detail. Look, the thing is with a password like password is easy to remember. There's a psychological reason behind that. Okay, it's a psychology thing. Like, it's like um, we don't want to remember with passwords, so we always use the simplest one. This also leads into another conversation about, okay, what if we make, and I see a lot of companies still do this, what happens if we make the users actually change password like every 30, 60, 90 days? That's not actually a well-known bad policy, because let's say if your password is whatever it is, what do you think people do when when you're forced, and I mean forced, to change your password? Well, you have that too. People never think about when people try to hack them. I mean, that stuff happened all the time. Um, wait, there's a rumor that guy. Hold on, hold on. You had to bring this mess up. Apparently, there is a running joke that the nuclear missiles launch code was 8 zeros. Okay, so Craftmaster is like, why do people make you do that? And then guess what happened? What happens is you know what everyone does. When you're forced to change the password, everyone just add a number one at the end of it. You have that problem. And then if you change the password or you forget it, and then you have to ask someone to go change the password, and that becomes a whole living nightmare. Okay, so you have that problem too. So okay, what do we do? Like, what's the better? What do we do? So storing the straight hash of the password, I digress. Let's come back to this. Alright, so storing the straight hash value of a password is not good, okay? Because you can expose a lot of people who are reusing this, who are using the same password. When they did a dump of the LinkedIn breach a number of years ago, they were finding like everyone was using weak passwords and tons of people were using the same stuff all over again. So here is, let's go back to the original. Is there a better way? So we had the problem of, okay, we store the hash value. That's not good. Plain text obviously not good. So is there a better way? Is there a better way to store passwords? There is. One way, and the very most, and this is the best and well-known way to store username and to store the password securely, is to append a set of random characters before the password. I repeat, just append the two, let's say a couple random letters or stuff before the password, then store the hash of that token or those couple random letters plus the password. So we're going to need a new column here. Okay. So I'm going to say, okay. So I'm going to append something called two random. I'm going to just give Chris C. Pfeiffer AA, BB, CC, DD, EE, FG. Okay? And right now it doesn't look so random. But these two random these characters here, AA, BB, CC, DD, EE, and FG, this is called a salt, a password salt. And what a password salt is meant to do is to add a little bit of randomness to the hash value of the password. Okay, so let's go to the MD5 calculator again. So let's do AA and programming. Let's do BB and football. Hold on, that's a good question. Very good question. How are you going to verify? Yep. How are you going to verify the validity? Every time the password you to add some random. Yep, you got it. So you're going to need to have a record of the salt too. CC plus whatever. There's a great question that was asked by Nashu. DD plus eggs. EE plus Silver Fox. FG plus football. There you go. And now we have our results. So now we added this little randomness thing called a password salt. And we append it to the original password, and then we hashed the value of the salt plus the whatever the original password was. And now, as you can see, that despite the fact that Samantha and Elon are actually using the same password, the hash value is actually the password is actually the same, but the hash value and the salt are different. Remember, Samantha and Elon are using the same password, but the salt is different, and hence the password hash is different. Okay? So, really? That's the way that you to secure a password? And the answer is, yep. Nash, you get it's fast. That's a good question. It hasting fast though? Yes, it is. Yes, it is. It is. So here, what is a cryptographic salt? There's a good post on Stack Exchange on this. Okay, the whole point is salt is a password salt is simply to make a password hash output unique even for users adopting common passwords. Its purpose is to make pre-computational based attack helpful. If your password is stored with a unique salt, then any pre-computed password hash table targeting unsalted password hash or targeting an account with a different salt will not aid in cracking your account password. Okay, so the simplest way to think about this is here's a good example. Is hash function salt and password. Common password like password 1 now magically becomes yada yada yada, which is unlikely to be found in a password crackers table. Okay. The salt can be stored completely in the clear in the database next to the hash value. This is important. Once the attacker has a database and wants to find a password, he needs to generate a pre-calculated table for each salt individually. That is a very expensive operation. Okay? That is a very expensive operation. Man, if there's a way that I can give gold stars to these questions, I will. There's some great questions here. Okay, so now what do we do? Okay, now here's the interesting thing. Oh, just on a side note, is that these days MD5 and SHA-1 are very well known to be broken. So I showed this to my security. Shadow.io. Here we go. SHA-1 is actually broken. This was like 4 years ago. So is an MD5. Alright? Alright. So now, let's get to what you've been all waiting for. How was stored... Alright. Max. Hold on. Max? Yes? How was salt stored... Okay. I think it's the time that you've all been waiting for. Let's actually crack some passwords. Let's actually not only crack some passwords, but let's understand how username and passwords and usernames and accounts are stored on a Linux-based system. Let's do that. We're getting a demo now, Encore. So I am going to log in to a system. Password is whatever, by the way. For real. So I have running a Pi-hole here. Now on this system, I am going to create a couple of users. Add user Anchor. And I'm going to give you, to add a user in Linux, is sudo add user Anchor, and then some username. And I'm going to give you a password. I can't tell you what it is. Yes. Okay. I'm going to add a new user too. I'm going to add Alon. And I'm going to say your password is... Can't tell you what it is. Yeah. I'm going to add another user. I got to add another user for add sudo add user. Nashisu. Okay, if you've been listening, how many users did I create? How many users did I just create on this system? Hello? Hello? Exactly. Okay, 3. All right. I was like, hopefully the internet didn't die. Yeah, I know someone actually had the internet go off like a couple days ago in the middle of class. It wasn't that good. All right. So where are usernames and passwords stored? All of that is stored in a file. Well, actually, I misspoke. I misspoke for a bit. The file that is in question is called /etc/PASSW. Let me clear the screen. Is more /etcs at PASSWD. This is a file where usernames, account information are stored. So it is in the directory /etcs, and the file name is PASSWD. And here you go. Look at that. As you can see, the 3 users that we just created are right at the last 3 lines here. The last 3 lines of the file. Ankur, Elon, and Nashishu. There you go. That's your account information. All right. Whoa. Wait a minute. Whoa. Okay, so what's missing? What's missing? What's missing is, wait a minute. What's the password? What's the password hash? What's the salt? What's all that stuff? That, my friends, is now in a file called, in the same directory /etc/shadow. Oh, permission denied. You need to have super user privileges to take a look at this file. Sudo more /etc/shadow. And here we go. This file, the /etc/shadow file, is where the password hash, including the salt, are stored. There we go. I see Ankur, I see Elon, and I see Nasty Soup. There you go. So there's 2 files that are important here. I'm going to go to my home directory. I'm going to make a copy. Actually, need to be root. I'm also going to make a local copy of the shadow file. So there's 2 very important files that we need to have. /gtc/ the PASSWD file and the shadow file. PASSWD has all the account information without the password hash. Shadow is the file with the password hash and salt. I need to make a copy of both. You'll see why. I'm now also going to make a change owner of the password of the file, or the password file to me, so I don't need root privileges. So I'm going to make a copy of. Okay. So now I have a copy of both the PASSWD and shadow file on my home directory. More shadow. Here it is. Here's the username and the username. And the hash, the password hash for Ankur, Elon, and Nashishu. Okay. What? What the hell does all this mean? Okay, Let's take a look at Encore. Encore, the username is here. His username is here. But then there's a colon. And then there's this long hash-looking thing. And then there's another colon. And then there's a number, a couple of numbers. So what the hell does this all mean? Well, let's understand how a password is hashed and stored on a Linux-based system. Okay? So, but you notice there's a pattern here. There's a $ number, $, yada yada, and then another $, and then another hash. Same pattern. $, yada yada yada, $, some number, $, yeah, up to another $. $, yeah, $, yeah. Okay. Now here is understanding. Let's understand how a shadow file actually works. Shadow file, the /etc shadow file stores the actual password in encrypted format like the hash of the password for a user account with additional properties related to the user password. Understanding /etc shadow format for system is okay. So basically each /etc shadow file stores secure user account information. All the fields are separated by a colon. 1 line per entry. So, the first one is obvious, is the username. The first part is the username. But the second part is where things get really into. It's the real meat and potatoes what we need to have. The second part is, yes, almost without saying, is the password hash. It's the encrypted password. Now, the password should be a minimum of 8 to 12, yada, yada, yada. Usually, the password format is stored in $ID, $salt, $hashed. The ID is the algorithm used on new Linux as followed. You see $1 starting off, it means it's MD5. You see a $2A is blowfish. You see a $5 to start off, it's SHA-512. And if you see $6 is SHA-512. If you take a look at what we just got, Encore, Alon, and Natsuchu, $6 is the start off of the password hash. That means that the password is to use SHA-512. And the thing after the first or second $, is the salt, then followed by the hash. So we have $6, that's the algorithm, the hash function, followed by the password salt. Then all this mess is the password hash. Same thing for Alon. Algorithm, password salt, password hash. Algorithm, SHA-512, which is very strong. You can see the key length is long. Password salt, password hash. There you go. There's also another article that explains everything. Same thing. Okay. So, now we have the PASSWD file. We also have the password. We have the PASSWD and we have the shadow file. I'm going to log off of here. What do you think we're going to do next? Now we have the PASSWD and we have the shadow files. I'm back on Kali Linux. What do you think we're going to do now? I'm going to make a copy. I want to actually download. A copy. Yep, you got it. On Kali Linux, I just downloaded the PASSWD and the shadow file that we made a copy of on that last machine that we were on. what we're going to do now on Kali Linux is we're going to crack the passwords. We're going to crack the password for Encore, Elon. Oh man, my memory's getting shoddy right now these days. And Nashashu. Okay? So, does anyone want to take bets on what Ankor's password is, Elon password is, and Nashashu? Anyone want to take a wild guess? Any wild guesses? We're going to take wild guesses only. So now, it is my pleasure to introduce to you all one of the quintessential tools, if not like one of the most well-known password crackers in the world, called John the Ripper. Not Jack the Ripper, not the murderer, John the Ripper. John the Ripper is free and it's open source. Okay, John the Ripper has been very, very well known. Okay, so the original use of John the Ripper was to find weak passwords on systems by system administrators. That's a good thing. So, I mean, we have system administrators, companies, and institutions who want to find weak passwords. You find a weak password, if you're an attacker, it's like the gateway to get into everything else. That's still the technique that attackers use up to this day, what the NSA uses. John the Ripper is a very famous and fast password cracker, originally developed for Unix and Linux passwords. Okay, so I'm gonna do Man John on Kali Linux. Here you go. John the Ripper, everyone. John the Ripper. Man John is one of the most, I believe it is one of the top 10 tools on Kali Linux if you install it. John the Ripper is a tool to find weak passwords of your users. Run John is really simple. It's just John and then a concatenated version of both the PASSWD and shadow file. Okay? Now, John the Ripper and any password cracking tool, they can be used for both good and, of course, for bad as well, too. The good is for system administrators and for people managing networks and systems to find weak user passwords. The bad, of course, if you want to gain unauthorized access for once you have accounts. Okay. So to use John, you just need to supply it with a password file and its desired option. If no mode is specified, John will try single first, then wordless, and finally incremental mode. Once John finds a password, it will be printed to the terminal and saved into a file called .john/johnpot. Okay? Now, what you need to do the first thing is before we start cracking passwords, I mean, all it is John and then some file. Right? Wrong. Not this. Okay, it's not that. What we need to do is this. We need to run a tool, man unshadow. What the unshadow is a tool which is part of John the Ripper that combines the PASSWD and shadow files. This needs to happen first before you run John the Ripper. The unshadow tool combines the PASSWD and shadow files so John can use them. So how does it work? Unshadow. Whoa. I'm going to clear the screen. I'm going to remember, I have the PASSWD file and the shadow file here, the local one. Unshadow, PASSWD, and shadow. Hit enter, and there you go. So both files both the PASSWD and the shadow file get concatenated. I think it will be better if I save it into a file, so I'm going to send it out to something called crackme.txt. So now, if I do vim crackme.txt, I have a whole bunch of usernames and account information. But in this case, I only want to crack Encore, John, Encore, Elon, and Nashashu password hashes. I don't care about these. I just want to delete these. Okay, so more crackme.txt. So here we are. Those are the 3 accounts that we want to crack. Okay. What's next? Next thing is John. John crackme.txt. So, now, this is by default. If I'm not mistaken, if you run John without any options, if you run John without any options, as we are here, what is going to happen is it's going to use like its own word list, which is like 25,000 words. John has his own word list that's used. I'm going to hit enter now. See what happens. You ready? So let's do some password cracking. Now we're on a virtual machine. So it's not going to have all the necessary hardware necessary. Virtual machines are always, I mean, they're doable, but it's always going to be slow. It's not going to take advantage of like the full performance of your actual machine. You want to do password cracking for real? You want to use like GPUs, expensive graphic cards, and rigs. I'm going to enter. Ready? You ready? I'm going to hit enter. Boom, got one already. Boom. Elon password? What's football? What's baseball? Sorry, Elon, your password got cracked. Yeah, silly goose. Mm-hmm. Keep it running. Now, it's not going to crack. I mean, it takes time to crack passwords. Okay? So what you want to do is when you're cracking passwords, you want to leave a system up and running for a while. Go out for a cup of coffee, go out for lunch or something, come back. I mean, people run these things for 24 hours a day. Still going. Still going. But this is terrible. I mean, all right. So we're getting bored here. We only got one account. We only got one account here. So we got one out of 3. How do we know? How does it know that's a valid password? What is a real password? Well, here it is. That we only got one. How does it know that a result is a valid password? What if the real password looked like random characters? Well, if the real password looked like random characters, it'll still say that as well. It's a good question. Still going. All right. While this is running, you may be wondering, okay, is there any ways that we could speed this up? The answer is yes, there are many ways to speed it up. One, of course, is to use things like more GPUs, expensive hardware. All right, look it. That'll be optimal, but really, your best thing, the best thing that you got to do to crack password is to use word list. And I want to introduce you to Daniel Meisler, who has this project on GitHub, who has this project for years, which I use all the time. It's called SecList. The SecList project on GitHub. What this is a security tester's companion. It's a collection of multiple types of lists used during security assessment collected all in one place. Lists include username, password, URL, sensitive pattern, fuzzing payload, you name it. Okay, this is a project been around for years. But one of the things that you see is that it has a list of passwords. And there are many, many files here. There are many passwords. So I'm going to show you on Kali Linux. So if I do a git clone, github.com/Daniel Secklist. Should take a while. It does take a while. It's like many hundreds, it's like hundreds of megabytes. Make a copy of this onto my VM. Clone the project. Get all the data. Well, is the password cracking stuff? Yep. Well, this sucks. Well, alright, I'm going to hit Control C. Now, the nice thing is if you hit the Control C, it's not going to crack the password that's been already cracked before. Nice. The best way to crack passwords is use word list. Use word list, use word list, use word list. Okay? And Daniel Meissler's sec lists have a lots and lots of password lists, and they're huge. Lists over 100 megabytes have been compressed. So these word lists can be huge. I mean, huge word lists here. Still going. Don't need this anymore. All right, so we cracked a launch password. What were those other two? I think I remember what Encore's one was. I don't remember Nash's Shoes one. Oh, I do know. Okay, I do. I think. All right. Now you see the sec list folder that I just cloned? CD sec list, CD passwords. So I can actually, let's take a look at the Dark Web 2017 Top 100. Copy selection, more. Okay, so here are a list of common passwords. This is in the top 100 list. Yep. Now we can take a look at more dark code. That's one of my favorite ones. More dark code. Dark code, so many of them. You may be wondering how many words are in that list. Word count, WC minus L, darkcode.txt, 1,471,056 entries. It's a lot of words. Okay? So now, all right, how do we use word lists to crack passwords? I'm going to copy this. Oh. Copy selection. So remember what we did before to run John the Ripper? Oh. John and then crackme.txt. What you want to do is this time minus word list equals, so the option is minus word list equals, nice clipboard, darkcode.txt, the name of your list that you want to use, and hit enter. So here we are. I'm going to try to actually crack me.txt with darkcode.txt. Let's see what happens. Ready? So we're going to do password cracking with word lists now. Hopefully we get the last two remaining ones. Alon's already been cracked, so whatever. We don't care about that anymore. Ready? So we're going to use the dark code word list to crack the remaining hashes in crackme.txt. That is Nash's Shoes and Encores. Two remaining passwords. Oh man. Yeah, it's cracking. Alright, so virtual machine, I don't know how slow this damn thing is. Maybe I can do it on my Mac. Oh man. I'm gonna CD to my desktop. SCP, Cali. I'm using an M1. Hopefully this actually would. Oh. I don't think I put that many CPUs on this damn on the virtual machine. Maybe that's why it's so slow. How many how many CPUs did I use for this one? 4 cores. Okay. Oh. Still running. So I got crackme.txt. I think it should. I think it should. I think it should. Hold on, hold on, hold on. Anything? Nope. Alright. I'm gonna control C out of this. I'm gonna now try to crack it on my Mac. Native. You always want to use native. Alright, so I got it. I already got a copy of Secless on my machine. Okay. Now, if you have Homebrew on Mac OS, John the Ripper is brew info John Jumbo. It is an enhanced version of John the Ripper. So you do brew install John Jumbo. I already installed it. Okay. Alright. Alright. Clear the screen. John. Okay? John's man, John. Oh. John. My word list. Let's do John crackme.txt. See what happens. I'm going to re-crack this again. Alon got cracked easily. Hey, we got 1 out of 3. That ain't bad. How accurate a password complete crack? I'm not entirely sure about that one. Proceeding with wordless. As you can see in my Mac, it says John password.lst rule wordless. Also, very important note is if you're cracking passwords, you only want to crack one type of passwords, not multiple. Like you don't want to be cracking MD5 and then SHA 512 at the same time. No. Don't. Crack them separately. Still going. I think Encore's one was not as. It should be a very, very doable one. Alon one was easy. which is good. Let that run. Maybe. Let's go to wordless mode now. Oop. Should go to crack me. Okay, here we go. So we loaded 3 half, but we already. Yeah, well, remaining 2 password hashes will do 2 different salts. We'll let it run. We'll let it run. Okay. Weird. Okay, so let's. Okay, so all right, so CG Happy Mac. Look, we're gonna actually continue on, but you lead to a final point, a very important final point that I want to make. Maybe it wasn't. We'll just let this thing run. So, one final point. Actually, you know what? I can actually comp open crackme.txt. I'll just paste the entire. See, everyone, if you want to chime in. I got 2 last messages here. So, Encore, Elon got cracked already. So, if you want some practice cracking cracking that again, sure, why not? Oh, yeah, I outsourced the work to you. Why not? I'm shocked that Encore's one was. It's not that complicated. Nah, still not going. Oh, we got a Balon one, which is good. A lot of people, I know Encore swears by this. If John the Ripper is not good enough for you, people love to use Hashcat. It's also free and open source. It is dubbed as the world's most fastest and most advanced password recovery utility. Free and open source as well on every single operating system. It's a little more complicated to use. A little bit more complicated to use. But lots of people end up using Hashcat. Lots of people end up using Hashcat instead of John the Ripper. And that's one. Okay. It was proprietary for a while. Huh. There it is. But CG Happy Mac leads to one last comment that's very important. Baseball took around like 2 milliseconds, and baseball 46 football equals 5 million millennia. And that leads up to a very important final point of today. And that is, I want to show you, there's a nice chart that shows you this. A very good chart. And I always find it. There we go. This one's good. Yeah, I use this one. This is an important one. The final point. Time it takes for a cracker to crack your password. Look, if your password is just numbers only, and it's only like 10 characters, it's going to be cracked instantaneously. If your password is all lowercase and it's actually like between 4 to 7 characters, it's going to be cracked instantaneously. Some passwords, such as what CG Happy Max says, like baseball 46 football, that's going to crack a long time. But if you take a look at this, if you take a look at this chart, you can see how long it takes for a hacker to crack your passwords. If it's a dictionary word that's in one of these word lists, too bad. You know, it's going to be cracked. If you're using dictionary words, you're going to be using dictionary words, it's going to be hacked. But there is a very important point here. There's a very important point, which is, as you can see from this chart, it doesn't matter if it takes instantly to crack a password or 7 trillion years or quadrillion years or 7 quadrillion years. It doesn't matter. Your password will be cracked, only given a matter of time. It doesn't matter. Look, yeah, we're not going to be around in 7 quadrillion years, but it will be cracked. So password complexity matters. If you don't want your password to be cracked, use lettercase, upper mixture of numbers, uppercase, lowercase characters, letters and symbols, as you can see. But it doesn't matter at the end of the day. At the end of the day, it doesn't matter if it's 1 second, 1 minute, 1 year, 1 century. Passwords will always be cracked, given a matter of time. And 7 quadrillion years is a matter of time. The only way that, and now it's gotten worse because so many websites have gotten hacked, and so people have made tons and tons of wordless collections. So you only got 2 defenses, okay? You only got 2 options. Number 1, always use 2-factor authentication for any account. These days, just entering a username and then just getting in, that's not enough. Now, 2-factor authentication is like the only solid defense against password cracking. That is, you enter your password and you enter it successfully, but then you have to enter like a 6-digit number to really show that it's from a device that you own, and to show it's really, really you that accessing the account. Okay? The only way that you can really defend yourself is 2-factor authentication. That's it. The other thing is, it also a big bonus. Use a password manager. Let's say like Bitwarden. Because these days it's not just people have 5 accounts. We're talking about 50, 60, 70 accounts. It's quite normal these days. There's no way that you're going to remember them all. When the case of Twitch happened, when Twitch got hacked and they told everyone to go change a password, I only used the Twitch password only one place and one place only. And so all I need to do in my password, it really is a habit and it really pays off. But instead of changing a whole bunch of passwords because I reuse the password reuse problem, no, I don't reuse the same password of Twitch password on other accounts. It depends. It depends. Unpassword just as unsafe as using 1Password though. Well, yeah, that's the downfall. If you use a password manager and you lose a master password, then game over. But if you're foolish, you don't use a master password for like sites like Twitch, Reddit, list goes on. Okay? So it's just a password manager's great management tool. So in my case, when Twitch got broken into, I only changed the Twitch password one time. That was it, out of like a couple hundred accounts that I have. I guess one last public service announcement. Yeah, I used to do that. About keeping 1Password but varying it slightly in a predictable way for each and every website. I used to do that, but it just got unmanageable. Like, then I just there's just too many accounts these days. There's this great website that was created by my friend. HaveIBeenOwned.com. You can actually see if user accounts have been cracked. So no information is stored whenever you typed in. I want to give a shout out to Troy Hunt, who created Have I Been Owned. So all you need to do is enter an email address or phone number. I'll just enter my work address. Has it been owned Oh, yep. 5 data breaches. LinkedIn, verification, and I've been scraped. I mean, people have different preferences. Some people love LastPass. Some people swear by 1Password. I use Bitwarden. But hell, it's better. I mean, these days, it's you got to use something because you have like 50, 60, 70, 90, 100 uh, accounts. Account. Oh, even that. 6. Oh, Jesus. I don't even know what the hell that is. Anyway, have I been owned? Great service to check if your account have been compromised or it's been a breach. Okay. Oh, weird. Start using 1Password. I think that's an add-on here. But I know Troy Hunt. I think he made a lot of this, like trying to make this open source. Want to give a shout out to Troy for Have I Been Owned. Um, Great service. But yeah, these days it's not a matter of if, but always think about it's just a matter of when you will get hacked. Whether it's your system, whether it's going to be your account. All right. So, other than that, well, it's still running. I'll let you. I'll just post the hashes if you're on the actual, well, the security course. I'll just post those hashes for you to play around and hack with. That's all I got for today. Long and fun day. Holy crap! It was still at the bees. Wow. All right. Yeah, I'm gonna outsource this for people to actually play and to hack around with. All right, next week we're gonna talk about vulnerabilities. Next week we're gonna do vulnerabilities. Yeah, the ugly issue of vulnerabilities and a problem that has not been unsolved. All right, folks. Happy hacking. Enjoy. See you next week.